So in this video, we're going to have a look at the Argand diagrams in a little bit more detail. So just like the Cartesian plane, this diagram is the graphical display for complex numbers. So it's in the complex plane. They're plotted like a vector in relation to the origin of the axes. So our horizontal axis represents our real number, so the value of A, and our vertical axis represents the imaginary part, part B. So you can see on this diagram, I've plotted the complex number 2 plus 3i, or 2, 3 in the complex plane on an Argand diagram. So we know from our calculations that we can actually add together and multiply complex numbers to find more complex numbers, essentially. So in our first question, I've got z1 equaling 2 plus 3i, which I've plotted. I've got z2 equaling negative 5 plus i, and z3 equaling negative 3 subtract 4i. So first of all, we're going to show z2 and z3 on the diagram above. So we've got negative 5 plus 1. So we've got z2 over in this direction. So I'm going to just label these. So we've got z1 and z2. And z3 is negative 3 in the real axis and negative 4 on the imaginary, I should say. So there's z3, negative 3, negative 4. So what we're going to do next is show the conjugate of z3. Well, we know the conjugate is a reflection in the real axis, so it keeps the same real part, which is negative 3, and it is the negation of the imaginary part, so it's going to be negative 3 plus 4i. So the conjugate of z3 is drawn in orange. So we're going to show the following sums using vector addition. Well, if we used vectors, then we could say that z1, so I'm just going to highlight that in green, plus z2, which is going to be heading off in this direction, is going to give us the result of z1 plus z2, which in fact actually comes out to be the conjugate of z3 as its solution. And this is using the idea of a vector addition, putting our complex numbers nose to tail on our diagram. So we should find that when we add z1 and z2 together, that they will in fact give us negative 3 plus 4i. And we can see that by completing that addition by hand. So if we had z1 plus z3, we know we would end up with 2 plus 3i plus negative 3 take 4i, and that will give us negative 1 subtract i. So if we pop that on our Argand diagram, so I'm just going to delete the ones that we've currently drawn on so we can see that a bit clearer. We've got z1 already drawn for us. We had z3 down in this direction here. And we can see that if we're talking about vectors, they're parallel, they're unlike parallel, they're actually in the opposite direction, z3 is, compared to z1. So if we had nose to tail, if we said z1 plus z3, we're going to end up with our solution of negative 1, negative 1, which is going to give us that vector, negative 1, negative I. We also can verify our additions and multiplications of complex numbers on our CAS calculator. I'm going to go down to the bottom of our screen and change it to complex form. And at the top, we can hit our keyboard, and I've just put mine to the right. I'm going to head to Math 2, and I can see that's where my I value is, where our I symbol is. So I can just quickly check that 2 plus 3i plus negative 5 plus I, which was our z1 plus z2, is actually going to give us negative 3 plus 4i, which we know is the conjugate of z3. The other thing that's actually quite nice is that if we use our action menu at the top and we hit complex, we've got lots of little things that we can do with our complex number. We could ask it to express the real value with the imaginary, or we could ask it to find the conjugate. So if you had -6 plus 12i as your complex number, it will tell you it's -6 subtract 12i. It's really quite great when we've got it in complex form when we're multiplying complex numbers. So we can just put a couple of complex numbers multiplied together here, and very quickly it will multiply those out for us. So let's have a look at question 2 together. We have an Argand diagram on the right. It shows 4 complex numbers, Z1 to Z4, but they're not labelled. And using the information given, we need to determine which ones are which. So it tells us that the real value in Z1 divided by the imaginary value, so A over B, should give us a number greater than 0. But if we do the same for complex number 2, the real number over the imaginary number should be greater than 1. It also tells us that Z3 is equal to the conjugate of Z2. So straight away I'm going to actually go for the third dot point, because it tells me that 2 of these complex numbers are reflections of each other, essentially, one being the conjugate of the other. So I'm thinking that these 2 here are the reflections in the x-axis, so these either have to be Z2 or Z3. So I'm just going to note that here. This could be Z2 or Z3 straight away. So in terms of using our first dot point compared to our second dot point, if I'm looking at the A values here, I've got an A value of 1 and a B value of 2. So this tells me 1 over 2. That's greater than 0, but it is not greater than 1. In our, for example, in this one here, I can see that my A value is 3, my imaginary value is -2. That gives me -1.5. It doesn't satisfy any of those dot points. So I'm going to leave that one alone for now. But going back to the Z2 or Z3 that I've highlighted in yellow, if we have a look at the one on the top left in the second quadrant, I've got an A value of -3 and a B value of 2. So -3 over 2. This also gives me -1.5. Whereas the one on the third quadrant, I've got -3 and -2. That gives me a value of 1.5, which is greater than 0. So this tells me this one must be Z2, which tells me that this one over on the top right in the first quadrant must be Z1. This one will be Z3, and therefore our last one in the fourth quadrant is Z4. So I'm just going to delete what I know they are not going to be. So just by using those clues, we can eliminate those that can and cannot satisfy those conditions. So now I'd like you to have a go at question 3, which is just displaying some complex numbers as vectors on the Argand diagram, starting with z equals 3 plus 5i. And then in question 4 is to display complex numbers z1 to z8 as vectors on the Argand diagram below. This is where using your CAS calculator in complex number mode is going to be very, very helpful. And then you can come back and check your solutions. Now, solutions for question 3, that we notice that when we keep multiplying by I, that the effect of that value creates these perpendicular vectors that are separated by 90 degrees. And in question 4, again, we see that the effect of multiplying by 1 plus I squared continually around with these vectors.